Hello, hello. All right. Greetings, YouTube. Beautiful mind here. So welcome, scholars. Let's see. So this will serve as our lecture for section 3.6. Okay. So we're continuing chapter 3 on applications of differentiation, and this will be section 3.6, marginals, differentials, and linearization. So today is Wednesday. Let's see, March. We have spring. I think we have spring break next week. So for our calculus for business students, this is our last meeting for this week. Then enjoy your spring break. We're just kind of continuing. So just hopefully you can take that time to get caught up, get some rest, do what you need to do so that you can finish out the semester strong. Okay, so 3.6 marginals, differentials, and linearization. A few objectives. We'd like to find marginal cost, revenue, and profit. We'd like to find delta y and dy. We like to use differentials for approximations, and we like to find the linearization of a function at x equals a. R of x and P of x represent respectively the total cost, revenue, and profit from production and sale of x items. The marginal cost at x given by C prime of x is the approximate cost of the x plus first item. So C prime is going to be approximately x plus 1, C of x plus 1 minus C of x. Let me think about that. Like the slope between, so you can kind of think of this marginal cost as like the slope between 2 points, right? So if you take your C of x item and you consider your C of x plus first item, and so that means your change in x is going to be 1, it has a unit of 1. So then if you say y2 minus y1 over x2 minus x1, you get this guy here, right? Something like this, the slope between these 2 points. Again, it's approximate. This is an approximation because again, C prime is usually the slope of the tangent line at a single point, right? So then C of x versus the next C of x plus 1, then that's going to be approximately the same as the slope of the tangent line at C of x, right? So we consider the next point. Again, we're dividing by 1 because the change in x in this case is 1. So then C prime of x is approximately C of x plus 1 minus C of x, right? So then if we isolate the C of x plus 1, C of x plus first term, basically we add this guy to both sides, then C of x plus 1 is approximately C of x plus C prime, okay? So first term, again, is approximately C of x plus C prime of x, okay? It's not exact, but it's close, okay? So, and I think that was the marginal cost. C plus first term, okay. So then the marginal revenue given by R prime of x is a similar discussion. It's going to be R prime is approximately R of x plus 1 minus R of x. So then the x plus first term in regards to the revenue is approximately R of x plus R prime. And then similar for marginal profit. Is given by P prime of x is approximate profit from the x plus first term. So then P prime is approximately P of x plus 1 minus P of x. So then the x plus first term is approximately P of x plus P prime. Okay. Okay, I feel better about that. So then given this cost function and revenue function, find each of the following: total profit, total cost. Let's give ourselves some, right, back up, just mind your own business. Oh, just mind your own business. Y'all know that reference. That might be before you guys' time. So that reference comes from Fresh Prince of Bel-Air. And I just saw where like they're redoing that series, but as a drama instead of a comedy. So I was like, I think it's on Apple TV Plus or One or whatever it's called. But that's an interesting spin. Like, I like that. I like that. That's unique. I've never seen that where they took a series and completely revamped it. It's like an alternate reality. It's kind of interesting. I haven't watched it. I struggle to watch dramas and like, it's a lot for me. I'd rather watch like comedies and things that are light in nature, but it's okay. So the profit, right? If you think of the profit from a business or a system, that's going to be the money generated minus the money spent. So the total profit here is just going to be R of X minus C of X. Okay, let's go ahead and write it. Let's just get a copy. I'm going to write these out, but A of X, the total profit. And again, that's going to be the money generated minus the money spent. Right? So in this case, it's going to be x cubed minus 12x squared plus 40x plus 10 minus, and I'm going to shrink these down, get it on the one line, 62. We need to distribute our negative as well. 62x squared minus 27,500. Okay. One line. To the right. My terms. An x cubed term. We got a negative 12x here. Let's highlight them. We got 12x squared and this guy. 62 and 12, 72, 74. 74x squared. 40 plus 40x, and then 10, 27,500 minus 10 is 27,490. So negative 27,490. Okay. Function. Find a total cost, revenue, and profit from the production and sale of 50 units of the product. So if we produce and sell 50 units, right? So for part B, I'm going to let 50 units. Revenue and profit. The cost of producing and selling 50 units is going to be 50 squared plus the 27,500. Because that's the rusty. Cool. Refresh. Okay. 60, that's not a 60, 62. Like this, it should be fine. Plus 27,500. Okay. 82,500. So total revenue of producing and selling 50 units. D cubed minus 12 times 50 squared plus 40 times 50 plus 10. 50 to the power of 3, 12 times 50 squared, plus 40 times 50. Weird. We got to go back. Make sure we're doing this. Okay, so let's just keep going with it. We get 9,010. All right, way less than the cost. So that's a no good. So then for this, the total profit of producing and selling 50 items is going to be that 9710 minus 182,500. And that's going to definitely put us in the red. Answer minus that 182,500. As long as our numbers are correct, it looks like that puts us in the red, almost $86,000, right? That's part B. So then the marginal cost, revenue, and profit when 50 units are produced and sold. So we said that the marginal cost is approximately X, the X item plus the X plus first item. But ABC, AB space. Want C prime 50. Like, because the other one was an approximation, all right? So let's take the derivative of these guys. Copy. Let's see what happens. All right. Instead of using that approximation, let's it says 50, yeah. Okay. Let's just go ahead and find C prime. All right. What is that? 120, 124? No. We're taking the right. So yeah, 124. C prime of 50. Let me see, 500, 600, 620. What's 124 times 50?
124 times 50 is 6,200.
Okay. So then revenue function. So then R prime X squared minus 24X plus 40. Okay. So then R prime of 50 is so squared minus 24 times 50 plus 40. Hey Siri, what's 3 times 50 times 50 minus 24 times 50 plus 40?
3 times 50 minus 24 times 50 plus 40 is 6,340. The derivative of a profit function and use that.
I'm just going to take what I need. Let's copy this. I just took what I needed. So then P prime uh, 148 x plus 40. Okay. So then P prime of 50 squared minus 148 times 50 plus 40. 3 times 50 times 50 minus 148 times 50 plus 40.
Times 50 minus 148 times 50 plus 40 is 140.
We should have been able to just say the revenue minus the cost. Yeah, and that would have worked as well, right? We do cost, marginal profit. So that's the profit, approximately the profit earned from the X plus first item. So the 51st item. Okay, let's highlight our results here. The marginal cost. Also need to highlight this guy, and we also got this guy. What do we do? How do we do this? Let me put my, let me charge that pin for just a moment while we go through this. Okay, so we got all of that. Let's see. X cubed, 7440, 27,490. X, okay, so there's there. And then I think we got all these results. So for part B, 182,500, 9710, negative 85,490. E. So when 50 units have been made, the approximate cost of the 51st unit will be $6,200. The approximate revenue from the sale of the 51st item unit will be 63, and approximate profit on the 51st unit is $140. Y equals this, and this, find delta Y, right? The change in Y. Let me think about this for a second. Is Y1? Okay. So let's see if that works. It should. It's back. So usually what? Delta Y means the change in Y. So that's usually what? Y2 minus Y1, right? So then our Y2, to put it in this terminology, this is the same as F of X plus delta X minus F of X, right? This is going to be equal to, so then X plus delta X is going to be 1, right? So we're finding F of 4.1 minus F of 4. We're basically saying 4.1 squared minus 4 squared. 4.1 times 4.1 minus 16.
4.1 times 4.1 minus 16 is 0.81.
All right. So when X changes by 0.1, Y changes by 0.81. Okay, this is what we get. There. Checks I usually leave as an exercise for you. You can see everything here. Give it a go. I would try just writing the original question and not using this answer, and then work through and see if you can get to the same conclusion. Right? If you follow along, then you're kind of gonna be led to that conclusion. But you want to, the recommendation is to start with the question and have everything else is blank. And you want to do that as often as possible, and then see can you arrive to the same conclusion. So for f, a continuous differentiable function and a small change in x, then f prime is approximately the change in y over the change in x. All right. So f prime is the slope of the tangent line at a point. For small changes in x, that's going to be approximately the same as delta y over delta x. So then if we use algebra, delta y is going to be approximately f prime times delta x. All right. So again, this is true for small changes in x. So approximate the square root of 27 using that delta y is approximately f prime times delta x. Okay. Okay. So we can let our f of x be what? The square root of x. All right, let's see. So if this is our f of x, then we can go ahead and identify our f prime of x. That's going to be 1/2 x to the negative 1/2. Okay, I'm gonna leave it like that. Like our x is 27. Delta x. Oh, okay. So let's try this. We're gonna say let x be what, 25, right? Because that's a square that we know, right? We know that square root, right? Let's see. Okay, so let's find delta y. So then delta y should be approximately, so then prime of 25 times the change in x would be 2, right? Because our x is 25 and we want when x is 27. So let's let our delta x, looks like our delta x is 2, right? When we let x be 25. So we're going to say times 2. Okay, I think this is okay. So if we keep going, that's going to be 1 times 1 over the square root of 25 times 2. Okay. So then delta y is going to be approximately, let me see, that looks like 1/2 times 1 over 5 times 2. It looks like these two guys cancel this, cancels this, and looks like we get a half, 1/5 in y. So then we should be able to say that the square root of 27 is the same as what? It should be the square root of 25 plus your change in y, but then we approximated the change in y. So this is going to be approximately 5 plus 1/5, which is what? Two. This will be a time if we were like live, I'd be like, hey, you guys have questions, because I feel like you should have questions. We can try to do a recap, and let's see how do we do, and then we'll do our best to do a recap. Okay, so we get 5.2. Again, it's approximately. Okay. It says let f of x be square root of x and x equal a number close to 27, for which we know the square root is easy to compute, right? So here we let x be 25. where the change in x is 2. Okay, so that's a good we got all that stuff, right? So then f prime was this, we got that. The change in y is f prime of 25 times 2.2, right? We got that. So now we can approximate 27. That's going to be the known plus the change in y. Or it's approximately the known plus the change in y. So then we get 5.2. Yay. Okay, let's do another one. Oh, quick check is an exercise for you. You have everything there. So then we have this definition. So for y equals f of x, for y equals f of x, we define dx called the differential of x by dx is essentially is the change in x, right? So the differential of x is going to be the change in x, which is your delta x. dy called the differential of y is going to be f prime times dx. Okay. So for our purposes, essentially we can use delta x and dx, we can just use them interchangeably. But then dy is f prime times dx. The way I kind of remember this, I know that f prime is dy by dx, and then through algebra, you get dy equals f prime times dx. Okay, that's just how I remember it. Okay. For this y, find dy, and then find dy when x is 5. Okay, so let's work on part A. Just said that dy is f prime times dx. Okay. For y prime, looks like we have to use the product rule. So the first times the derivative of the second is going to be 3 times its 4 minus x squared times a negative 1. Right. So first times the derivative of the second, but the second you have to do the chain rule. So derivative of the outside times the derivative of the inside. First times the derivative of the second plus the second, which is this guy, which is 1. So what I'm going to do is move this down just to get it on one line. I'll put it here. And dx, so then for part A, our dy is going to be f prime, which is all of this. To write it, I'm not going to expand it. We could expand it. I'm just not going to do it right now. Yeah, I'm just not going to do it. Unless, I mean, I'm just not going to do it right now. Minus, so that's going to be what? A negative 3x times 4 minus x squared plus 4 minus x cubed, right? We can factor out a 4 minus x squared. Let's do that. Okay. Oh, and then we need to say all of that times dx, right? But I'm going to factor out that 4 minus x squared. And I'm going to kind of rearrange it. If we factor out 4 minus x quantity squared, okay, second part, we're going to be left with 4 minus x. And then from the first part, we're going to be left with minus 3x. And then basically all of that times dx. That's going to be what, 4 minus 4x? So I don't have to, just for the sake of space. 4 minus 4x. That's not an x. Okay. So we need some space. X is to find dy. So we got this for dy. And this. X is to find dy when x is 5 and dx is 2. So then b. Okay. So that's going to be 4 minus 5 squared times 4 minus 4 times 5. And dx is times 0.2. So 4 minus 5, -1, so that's a 1. So I'm just going to highlight that as this collapses to 1. 20, 4 minus 20 is a -16. 0.2. I think it's a -3.2. Page. I'm just reading it in just a moment. Bend it back as much as we can. Need this guy, delete. Okay. Good. All right, let's see what happens. So we get this 4 minus x squared, 4 minus 4x dx, and -3.2. Did they keep going? So for part A, they got -4. Let me see. Yeah, because we could factor out a -4. We would have x plus 1. This one, yeah. And there, yeah. Factored out a -4 from the second term over here. We left it here. They just factored out that -4. Okay. E, we got -3.2. You see it there. The definition, let me see how many slides. Okay. Let y equals f of x be differentiable at x equals a, then the linearization of f at x equals a is given by this. So linearization, I'm under the impression that this basically is a direct way to find the equation of the tangent line at a point. You know, like if we consider a curve and we consider a point on that curve, the derivative, what it does is tell us the slope of the tangent line at that point, right? It only tells us the slope. So if we wanted the actual equation of the tangent line at a point, then we have a point and the slope. We would have to use the point slope formula. So this is a direct application of the point slope. Y minus y1 equals m times x minus x1. So then if you add that y1 to both sides, you get this guy, right? So this comes out of the point slope, where you're given a point and a slope. So this is a direct formula, so you can get the equation of the tangent line at a point, right? This is the equation of the tangent line of to f at x equals a, okay? So find the linearization of this guy with these conditions. Let's see. This guy, f of a, okay, let me just do this. And we'll do this in green since it's the formula. Y equals f of a plus f prime of a times x minus a. Right, and we can derive this basically from the point slope formula. I'm just using it like of this function at x equals a. So let's fill in the different components. Let's see, so f of a, so then f of a, that's going to be what? F of 27. So then cube root is 3. All right, so f of a is 3. F of a, so that's x to the power of a third. So that's going to be 1/3 a to the power of negative 2/3. Be 1/3. A is what, 27 to the power of a negative 2/3. Right. 1 over. So the cube root of 27 is 3. 3 squared is 9. So then this should be 1/3 times 1/9, which is 1/27. Okay. And then x is 28. Of the tangent line is going to be f of a, which is 3, prime, which is 1/27, x, which is 28, 27. So 3 plus 1 over 27. Hey Siri, what's 1 divided by 27?
1 divided by 27 is about 0.03703.
0. 1 divided by 27. I'm going to do 0.037 bar. All right. So wait a minute. Oh, we wanted an equation, right? Because we want the equation of the line. All right, it should be this guy. So this is our linearization. The tangent line when x is 28. When x is 28, 0.037. So then we get 3.037, or in other words, 3 and 1 over 27. Again, this part is repeat. Okay, let's see, how do we do, right? We got the equation of the tangent line, and then tell us. So at x equals 28, so that linearization tells us the equation of the line at any point. Then given the point, I think it doesn't tell us a derivative because the derivative is a slope. The equation line. So what is this line telling us? Oh, is that our dy? The linearization? Let's see what happens, right? So to construct a linearization of f with these conditions, we need to find f of a and f prime. So f prime of 27 was 1 over 27. So then y equals this. And okay, so they simplified, that's fine. All right, I think we probably could have simplified it. I didn't even think about it. Distribute the 1 over 27. You get what, -1. So then 1 over 27x plus 2. All right, and I think they have that. We should have simplified. So then to approximate, okay, so this is an approximation of cube root of 28. 3.03, you see it there. So note that cube root of 28 is approximately 3.037 bar. Well, on a calculator, it's going to do all of this. Interesting. Close. Both of these are approximations. This is interesting. Do something that was known to approximate something that was unknown. So it was similar. It was similar to an example that we did earlier. Okay, that was fun. So if C of X represents the cost of producing X items, then the marginal cost C prime is a derivative, and C prime is approximately C of X plus 1 minus C of X. Thus, the cost to produce the X plus first item can be approximated by C of X plus C prime. It's a similar discussion for the revenue and the profit. In general, profit is revenue minus cost, or P of X is R of X minus C of X. In delta notation, the change in X right here the change in x is x plus h minus x, which is just h, right? Once you simplify, the change in y is f of x plus h minus f of x for small values of delta x. For small values of delta x, we have the change in y with dy by delta y by delta x is approximately f prime, which is equivalent to if we solve for delta y, f prime times delta y is approximately f prime times delta x. The differential of x, dx is equal to delta x. Since dy by dx is f prime, then we can say that dy is f prime times dx. In general, delta y is approximately, dy is approximately delta y. And approximation can be very close for sufficiently small changes in dx. Okay, all right. So that was an adventure. Hopefully you were able to get what you needed. I'm available if you guys have questions. It's again, hopefully you've all been like working together. You've been working with the tutors and getting support that you need. So again, we have spring break next week. Enjoy your spring break. You know, once you leave college, you get out into the world and you start getting it for yourself. You know, these are precious hallowed times, right? Because when you get out there, you get responsibilities. Then it's a good chance that you won't have this kind of time to yourself. So take your time, do what you need to do, get caught up, position yourself for success. You know, get plenty of rest, do what you need to do, then come back strong so we can finish this out. All right. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, take care, guys. Peace.